heart of mathematics, the powerful remainder and factor theorems, lies in their ability to unlock the hidden secrets of polynomial equations. Welcome to the 8th episode of Equationators math class. This is student teacher Dan. Today, we're going to talk about the first most-based module of mathematics in data, providing the remainder and factor theorem. Are you ready? Halina't Math Tutor.
Here are the learning objectives. In this lesson, you are expected to prove the remainder and factor theorems and find the remainder using synthetic division or the remainder theorem. Before we start, let us have this activity. Divide the polynomial function f of x is equal to x cubed minus 2x squared plus x minus 3 by x minus 2 using synthetic division. Last module, we have discussed about dividing polynomials using the synthetic division. With that, we have to get the coefficient first of the function. Then we have 1, negative 2, 1, and negative 3. Then, using the divisor x minus 2, we have to get the value of a. That is 2. Then, perform the synthetic division. First, bring down the first coefficient, which is 1. Then multiply it by the divisor 2. We have 1 times 2, which is 2. Then add it. We have negative 2 plus 2 will give us 0. Then 0 times 2 will give us 0. 1 plus 0 is 1. Multiplying it again, we have 1 times 2, which is 2. And lastly, negative 3 plus 2 will give us negative 1. Since the divisor is x minus 2, let us try to evaluate the function at x is equal to 2. With that, we have f of x will be equal to x cubed minus 2x squared plus x minus 3. When we evaluate this, we have to substitute all the values of x by 2. Then we have f of 2 will be equal to 2 cubed minus 2 times 2 squared plus 2 minus 3. Then we have 8 minus 2 times 4 plus 2 minus 3. Simplifying this, we have 8 minus 8 plus 2 minus 3. And lastly, we have now f sub 2 is equal to negative 1. When the function was divided by x minus 2, the remainder is negative 1. And also, when the function was evaluated at x is equal to 2, the result is also negative 1. This problem leads us to our lesson, which is all about the remainder theorem. Now, what is remainder theorem? Remainder theorem, if a polynomial p of x is divided by x minus a, then the remainder is r is equal to p of a. In the given example, when f of x is equal to x cubed minus 2x squared plus x minus 3 is divided by x minus 2, the remainder is equal to f of negative 2, which is negative 1. When a polynomial is divided by x minus a and the remainder is 0, then we can say that x minus a is a factor of the polynomial. Through the remainder theorem, we now know that the remainder is related to evaluation of the polynomial at the point x is equal to a. We are then led to the factor theorem. And now, what is a factor theorem? If p of a is equal to 0, then x minus a is a factor of p of x. Conversely, if x minus a is a factor of p of x, then p of a is equal to 0. When x cubed minus 3x squared minus 9x plus 27 is divided by x plus 3, the remainder is 0. Therefore, x plus 3 is a factor of the polynomial function. Let us now have an example. Find the remainder when x cubed plus 2x squared minus 5x plus 2 is divided by x plus 3. We can find the remainder in two methods, by synthetic division or by remainder theorem. Using the remainder theorem, then we'll have p of x, the polynomial function of x, and then we will evaluate it using the divisor x plus 3. The value of a is negative 3. Then we have p of negative 3 will be equal to negative 3 cubed plus 2 times negative 3 squared minus 5 times negative 3 plus 2. Then evaluating all the exponents, we'll be having negative 27 plus 2 times 9 minus 5 times negative 3 plus 2. Then multiplying, we have negative 27 plus 18 plus 15 plus 2. Then finally, our p of negative 3 will be equal to 8. This means that using the remainder theorem, our remainder is equal to 8. We can also check the answer using the synthetic division. Using the polynomial, get the coefficients. We have 1, 2, negative 5, and 2. Using a, we have negative 3. Then performing the synthetic division, bring down the first coefficient 1, multiply it by negative 3, we have negative 3. And then 2 plus negative 3 will give us negative 1. Negative 1 times negative 3 is 3, and negative 5 plus 3 is negative 2. Then, negative 2 times negative 3 is 6, and 2 plus 6 is equal to 8, meaning the remainder using the synthetic division is also equal to 8. Then, using the remainder theorem and synthetic division, we now get the remainder which is equal to 8.
And that's all for today. I hope that you enjoyed